The first thing I'm going to explain, hello Linomta, welcome, is the conversion between improper fraction and mixed numbers. Okay, so if you look at the fraction 7/3. First of all, what is an improper fraction? Can anyone tell us what an improper fraction is? Before I continue, let's clarify quickly what an improper fraction is. Anyone? Remember, you're allowed to raise your hand and just speak to me because typing takes a while sometimes. Anyone know what an improper fraction is? I know you guys know. Don't be shy. We're all here to learn, right? Okay, never mind. Nobody wants to speak to me. That's fine. There we go. Hello, Kyle. Never mind. I put your hand down by mistake. There, I unmuted you. Kyle.
Hello, ma'am.
Hello.
An improper fraction is when the numerator is bigger than the denominator, ma'am.
Beautiful. That is correct. And thank you for being the first one to unmute today, Kyle. You have made this lesson wonderful. Okay. Seth, it's fine as long as you see a mistake. Okay, Seth, does it make sense? So when the number at the top, otherwise known as the numerator, is greater than your denominator, actually the definition is right here, then we call that an improper fraction, right? We can then change it to a mixed number. A mixed number contains a whole number as well as a fraction next to it. Right, so now let's look carefully. 7/3. That means we have 7/3, right? So check here. This is 1/3. We have a 2/3 and we have 3/3. So this one over here is 3/3, but that's the same as what, guys? We can just simplify 3/3 as? What can we simplify 3/3 as? 1. Thank you, Amuhelang. That is correct. We can simplify it as 1. Nice, Seth. And then we have another one, 3/3. And that's another 1. And then the last one, we only have 1/3. But altogether, we have what? A full 2 and a third. Do you guys see that? So to convert from improper to mixed, you need to figure out how many of the denominators can fit in the numerator. So how many 3s can fit into 7? 2 of them, isn't it? Because 2 of them would make 6/3. But then we still have a third that's left over, which is why it ends up being 2 and a third. All right, I hope I made sense. And now how do we go from mixed number to improper fraction? How do we go the other way around? Does anyone remember? Does anyone want to try and share with us? So if I have 1 1/4, right? My handwriting looks terrible. Nice, Seth. I'm going to go back to an example because Seth has given us the proper way to do it. Okay, this was 2 and a third. So Seth is telling us that we times at the bottom. So you say 3 times 2, and then you add 1, and that's how we end up at 7/3, because 3 times 2 will give you 6, and if you add 1, that will give you 7. So at the bottom we times, at the top we add. Just remember it like that. Let's do another example of this. If I have 1 1/4, at the bottom I times, so I'm going to say 4 times 1, and then my answer, I'm going to add 1. So what is the improper fraction of 1 1/4? What will the improper fraction of that be? Anyone? So you say 4 times 1, and then you add 1, and you put it all over 4. So the answer is going to be over 4. What's 4 times 1 plus 1? Anyone? Thank you very much, Mine. Welcome. I didn't see you were here. Welcome, welcome. All right. So that's how we convert both ways and Chetza. Now we have mixed numbers and it says convert these into improper fractions, but there's an additional instruction here because it says in the simplest form. Okay, in the simplest form. I'm going to make this a little bit bigger so you guys can see properly. I feel like they might be a little bit small. Okay, let me do this. Hopefully that's a bit easier to see on your side. So what I was saying is we are taking improper fractions. We're making them we're taking mixed numbers, excuse me, changing them to improper fractions in the simplest form. So my first one is 6 and 9/11. So again, at the bottom I times and at the top I add. So what is 6 and 9/11 as an improper fraction? 11 times 6 is what? We should know this off the top of our head. We shouldn't need a calculator. What's 11 times 6? Thank you very much, Chetza, for the final answer. Yes, Yolanda, it would be 66. And if you add 9, so 66 plus 9, nice, Seth, that is 75/11. Now they said simplify, right? Simplest form. Is there any common factor between 75 and 11? No. So this is our simplest form. We are done. All right, let's do number B. Excuse me. This says 25 and 300. Again, times at the bottom, add at the top. Now, what is 25 times 100? What is 20? Thank you. And then plus 3. We have much more participation today. This makes me feel very good. If you add 3, thank you. This is 25/100. Do you guys think there is a common factor between 2,503 and 100? What is the common factor, Seth? What is the common factor? 10. Can we divide 2,503 by 10? I think that 3 is throwing us off a little bit, right? That 3 is throwing us off a little bit. This guy. If it was just 2,500, then yes. But now there's a 3 in the mix. There we go. So no. Okay, let's go to number C. We have 8 and 2 25s, 25ths. The vocabulary always throws me off. Now we have 25 times 8. How much is 25 times 8? And then plus 2. 202 over 25. Now, do we have a common factor here? Do we have a common factor? 25 only has factors of 5. Can 5 go into 202? No. So this is my simplest form. Let's do number D. 4 and 5/6. Final one. We're on fire. See, guys, when we participate, these lessons go much quicker. Times and plus. Okay, 6 times 4. 24 plus 5. 29/6. Any common factors? What are the common factors? 3. Ooh, can 3 go into 29? Let's check. No, because 29 is what? What is that special name we call for numbers like 29? 29 is a nice. It's a prime number. So it does not have other factors except 1 and itself. So this is a prime number. Okay, thumbs up, thumbs down. Are we good with these? Let's have a thumbs up and a thumbs down. For everyone who's new, you go to reactions and you give me one of these if you understand, or you give me one of these if you do not understand. Nice. Okay, there are 26 of you in here. I expect many more thumbs up than that. Nice. There we go. Okay, now I want us to do one where we actually do have to simplify because none of these were simplifiable. Okay, screenshotters, have we all done your screenshots? I hope so. Okay, I hope we've all done our screenshots because I'm going to move to the side here and I'm going to give us number E. Okay, and I'm going to say 2 and 4/20ths. Okay, so let's simplify this one. 20 times 2 plus 4. What is my improper fraction? 20 times 2 plus 4. What is my improper fraction? It is 44, but that's not my fraction. That's not a fraction. That's my numerator. 44 over what? Thank you, over 20. Now, can we simplify 44 over 20? Yes. How would we do that? How can we simplify 44 over 20? You look further. It's called a common what? I've been using it the whole lesson. Factor. Beautiful. So what is a common factor between 44 and 20? Yes, Chantal. Nice, Butlali, it is 4. So we're going to divide the numerator by 4, but we're also going to divide the denominator by 4. And this is going to give us how much? What is 44 divided by 4? 11. And 20 divided by 4? Over 5. Okay, do you guys agree that these two fractions mean the same thing? 44 over 20 and 11 over 5 mean the same thing. Do you guys agree? Yes. So what are they called? What are they called? We have a special word for such fractions there. Anyone have an idea? I know you guys know. You're probably just doubting and don't want to say it out loud. No, I mean fractions that mean the same thing. For instance, 44 over 20, we said is the same, has the same meaning as 11 over 5. So what type of fractions are those? The ones that mean the same thing. Okay, last chance for anyone to guess. No. I'm going to start writing it. Does anybody know yet? I gave you guys a clue. Equivalent fractions. That's my person Seth. Equivalent fractions. Okay, I forgot to disable that. Give me 1 second. There. So it's equivalent fractions. Okay, so equivalent fractions means that they have the same meaning. Okay, so you can either multiply the denominator and numerator by the same number, or in this case, we divided the numerator and denominator by the same number. Okay, so that takes us to the next part. See, I knew what I was doing. I had a vision and mission. Vision and mission. Okay, I'm going to make this a little bit bigger as well so you can see. It looks fine to me, but I know you guys might need to see a little bit better. So there's my definition that I gave you guys, right? To find an equivalent fraction, you can either multiply the numerator and denominator by the same number. Okay, so let's see here. We initially had a third, 1 over 3. And we've decided that we're going to multiply both of them by 3, which will then give us 3 over 9. But do you agree that a third and 3 nines means the same thing? They mean the same thing. Okay, so we call these equivalent. They're not equal because they are not the same numbers, but they are equivalent. Okay, so first example has multiplied both of them, or you can divide the numerator, and using blue was not funny, it was not smart. Seth is asking a very good question. When do we cross multiply? When we are dividing or multiplying, Seth. Okay. When we are dividing or multiplying fractions, that's when we cross multiply. I'll show you just now. Okay, so now that we know what equivalent fractions are, we have a couple of fractions here, and they have asked us to give the equivalent for each of these fractions. Okay, so initially I had for A 7 over 10, but now my denominator has become a 40. So what did I do to 10 to end up at 40? What do you guys think I did to 10 to add up at 40? Nice, Seth. I multiplied it by 4. So what I do at the bottom, I have to do at the top. So if I times the denominator by 4, then I have to times the numerator by, nice, Mene. I have to times it by 4. And now we know that our answer is 28 over 40. In this case, you don't simplify because you're going to end up right back at 7 over 10. Do you see that? They just wanted the equivalent fraction. Okay, let's go to number B. Number B started off as 36 over 54. But now my numerator is 6. So what did I do to 36 to end up at 6? Divided by 6. So then if I divided by 6 at the top, I have to divide by 6 at the bottom. So then what is 54 divided by 6, my good people? 9. You see, once again, we do not have to simplify because they didn't ask us to. All they wanted in this case was the equivalent fraction. That is one thing that we need to take note of in math and in our math exams, okay? Don't waste time doing unnecessary stuff or you won't finish, but also read instructions carefully. Okay, the third one is 2 over 9, and this is equivalent. I was about to say equal. It's equal to something over 63. Now, how did we get from 9 to 63? Times by 7. You guys are on fire today. So then I have to times both by 7. So then what is my new numerator? 14. Beautiful. Let's do the last one. D has changed to 15 over 25. So what did I do to 5 to get to 25? Or we can go backwards. What do you do from 25 to 5? Because we need the one that is on the right, right? What do I do to 25 to get to 5? We're going backwards this time. I divide it, thank you, by 5. So then what do I do to the 15? So then what do I do to my 15? I divide by 5 as well. So what's my old numerator? What was my original numerator? It was 3. Nice, Wage. Nice to see new names in the chat. Anofani and Jenna. Okay. So these are equivalent fractions. Okay. Now, I was busy asking us going forward and back and back and forward. What do you call these symbols? Okay. When I'm going backwards from divide, nope, I want to use colors. When I go from divide and I'm going backwards, why is it so thin? Oh, it's because it's the pen. I was like, something is not right. If I'm going from divide to times, right? That is the backwards of each other. So actually, let me do this to show you that these two are linked. Okay. But also, what is the backwards of addition? What is the backwards of adding? subtracting. Okay, so what are these called, guys? There's a special term. Nice, Tebogo. Tebogo was just waiting for me to ask. These are called inverse operations. Okay, these are called inverse operations. Right, I'm going to go back for screenshotters, and while you guys are screenshotting, here we go. I am going to ask for my thumbs up, thumbs down for equivalent fractions. We're on fire today. We're moving fast. Yes, 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 yes. I love it. All right. Now I want us to convert, right? How many types of fractions do you guys know of? Let's hear if we know. How many types of fractions do you guys know of? Anyone? How many types of fractions? Okay, 4 or 5. Okay, let's name them. Let's name them. Number 1 is my what type of fraction? A common fraction. Okay, that's fine. A proper fraction. An improper fraction. A mixed fraction. Equivalent is not quite part of these. What else, guys? There's one more I'm looking for that nobody's saying. Let's hear. What other type of fraction do we have? There's one more that I'm looking for. People who said 5, were you counting equivalent? The other one is a decimal fraction. Nice, Chantal. Okay, so we are going to learn. Okay, first I need to fix our vocabulary here. I know common fraction was used for a very, 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 very long time in math, but we need to fix that and replace it with the word proper. Okay, because technically all of these are common, right? Every day we interact with proper fractions. Every day we interact with decimal fractions, improper fractions, mixed fractions. So all of them are now categorized as common. All right, so the word that you want to use for such a fraction is proper, not common. And then, of course, we've already dealt with improper fractions as well as mixed numbers, as well as decimals. We're about to deal with them like 0.14. Okay. Now, this is my summary diagram for converting these types of fractions, okay? So I'm going to do this and make it bigger for us again and move this guy down first and then this guy down. So if you guys want a nice summary, take a screenshot of this, okay? We're going to be going from a fraction to a percentage to a decimal, okay? Now let's see how we do that. Give me 1 second. This guy. Oop. There we go. Okay. So if you look carefully here, if we start from a fraction, okay, so you must times the top by 100 and divide by the bottom to make a percentage. Are we listening? So if I have a half, my pen, there we go, 1/2. Okay, It says you must times the top by 100 and then divide it by the bottom. What is 1 times 100? What is 1 times 100? 100. Okay, I should probably have some sort of sum there, otherwise it just looks strange. So first step is times the top by 100, and then you're going to divide by the bottom, which in this case is a 2. So you're going to say 1 times 100, which you guys have told me is 100. And if you divide it by 2, what does that give you? 50. So a half is 50%. Is that correct? Is that correct? Yes. Okay. So all you have to do is times the top by 100 and then you divide it by the bottom. Now, if you are at a percentage and you want to go to a decimal, you divide it by 100. Why do we divide by 100 specifically? Does anybody know? Does anybody know why we divided by 100? Anyone have an idea? It's because percentage is out of what? Percentage is always out of 100. Okay, so if you want the decimal, then you must divide it by 100 because it came from a percentage, which means it was out of 100. So I'm going to write here, percentage is out of 100. Okay, and then you get to your decimal. Now let's look at the opposite. Now, if we were dividing at the bottom, we will be timesing at the top because inverse operations. That's it. Okay, so the first one is simple and straightforward. Okay. Now, for this one, it says you must put it over 100. Remember, first we were timesing by 100, but if you put something over 100, what are you actually doing? If I say 5 over 2, it's the same as dividing. So it's still inverse operations. Are we still with me? So if I have 40%, for instance, and I want to write it as a fraction, I'm going to say 40 over 100, but that's not my final fraction. What do I have to do to this fraction? What do I have to do to this fraction, guys? Divide it so we can simplify it. You agree? So I will divide the top and the bottom by the same thing, which is what? What's my common factor between 40 and 100? My common factor. Let's try and find the highest common factor between 40 and 100. Nice. Bohlali is always waiting with my common factors. It is 20. So then my fraction will be, what's 40 divided by 20? That is a common factor, Seth, but 20 is the highest one. So if you divide it by 10, you're going to have to divide it again by 2. It is 2. Then at the bottom, what is 100 divided by 20? It is 5. And there's your fraction. Okay, before we do our table, I know I said a lot of information. If anyone has a question, this is your chance now to ask. If anyone has a question, now is the time to ask. No one? Okay. Then, before we go to our lovely brain break that I have for us today, I want us to do this table. And of course, I'm going to make it a bit bigger. When I was setting this lesson, everything looked much bigger to me, but I realized on your devices, it might look a little bit small. Okay, where's the 20 coming from? It's a common factor. Maybe I should write that down. Remember, Bongo Musa, factors are the numbers that you can divide it by. So let's say I want the factors of 40, okay? What can you divide 40 by that won't give you a remainder? You can divide it by 40 because it's going to give you 1. You can divide it by 20. You can divide it by 10. You can divide it by 5. What else? You can divide it by 4, by 2, by 8. Am I missing any of them? Well, there's a 1, obviously. Just try to write it in order, okay? Don't do what I'm doing here. So it's 1 times 40, 2 times 20. No 3. 4 times 8. Nope. 4 times 10. 5 times 8. I think that's all of them. So do you see, Bongo Musa? These are factors. But now, out of these factors that I have to look for one that also goes into 100. Right. So the factors of 100 will then be 100, 50, 3, nope, 4 is 25, 20, not 15, but 10. Okay, 10, you times it by 10, and then 5 and 4 and 2 and 1. So they share a few of them. I agree, right? They both share a 2. They both share a 4. They both share a 5. But we want the highest one. So out of the ones that I've listed here, which one's the biggest one? Which one's the biggest one out of the ones I've listed here? 20. So that's why we went with 20, because it gave us our simplest form. If you look at the rest of them, 40 doesn't go into 100, and 25, 50 don't go into 40. Okay, did I answer your question, Bongo Musa? So you basically have to find that common factor. Wonderful, wonderful, wonderful. Okay, so answers have been given. Question has been answered. Now I want us to fill in my table. Okay, 77 over 100. What are we saying? You said times by 100 and then divide by the bottom. So 77 over 100 is what as a decimal? Who knows? What is it as a decimal? Unless you guys want to start by percentage. You want to start with, yes, it is. It's 0.77. How did you guys get 0.77? I know you used a different trick. Does anyone want to share what that trick is? No? Okay, that's fine. As a percentage, so you take 0.77 and times by 100. Nice. 77%. Okay, first one off without a glitch. This time we have a decimal. Decimal to percentage. Decimal to percentage is 3 times by 100. Nice. 44%. And then fraction, we said you put this over 100. But I can simplify it. What can I divide into 44 and 100? What can I divide by 44 and 100? I'm going to put it here, my highest common factor. 2, yes, but 2 is not the highest one. Does anyone know what the highest one is? Nice, Anati. It is 4. So I'm dividing by 4 over 4. So what is 44 divided by 4? 11 over 100 divided by 4, which is 25. I think I should write these fractions next to each other. Otherwise, you can barely see what I've written. So I'm going to write it like this. So it's 11 over 25. Nice. Now we're starting from my percentage and going backwards. 46.7% as a decimal. There. Times, nope, as a decimal. So percentage to decimal divided by 100. So what is my decimal here? What is my decimal here? If I say 46.7 divided by 100, I will get what? Does anybody know? I'll get 0.467. Okay, thank you, Buhlali. And then as a fraction, it will be 46.7. Okay, I'm going to do it on the side and then we'll rewrite the final answer. 46.7 over 100. Is it going to be easy simplifying it with a decimal? It's going to be very difficult to find a common factor with a decimal, right? So just write it as 46.7 over 100. Okay, the next one says 36 over 50. What do we have with what problem do we have with this one? We have one problem. We want it to be over what? Over 100, but it's over 50 currently. So how do I make it over 100? I have 36 over 100. How do I make it over 100? Times by 2. Do you see why we needed to learn our equivalent fractions? Times 2 times 2. What's my new fraction? 72 over 100. Okay, so now we know it's 72 over 100. So as a decimal, it will be 0.72. Beautiful. And as a percentage, 72%. Okay, nice, guys. We're on fire. Now we have 0.94. Let's start with percentage because that's the easiest. Percentage, 94%. Now let's go to fraction. We're going to start off with 94 over 100, but I can definitely simplify this to what? Okay, let me start with what do we divide it by? I can divide them both by? They're both even numbers. That's a very big clue. I can divide them both by what, guys? By 2, because they're even numbers. Do you see? Can divide them both by 2. So then what is 94 divided by 2? Thank you, 8. It is 47 over 50. So this will then be 47 over 50. Okay, last one, 125%. If you say 125 divided by 100, what are you going to get? 125 divided by 100. Thank you. 1.25. Okay, and now we want it to be a fraction. It's 125 over 100. What can go both into 125 and into 100? Yes, 5. What's the highest common factor? 25. If you divide it by 5, that's fine. You're just going to have to divide it the second time. Okay, Minnie? And that's fine. There's nothing wrong with that. So what's 125 divided by 25? 5 over 4. Nice, sweet. It's 5 over 4. So my fraction is 5 over 4. Okay, you guys flew through this table, so I feel like I need to do a check-in. Did I lose anyone anyway? Give me a thumbs up or a thumbs down if I lost you along the way somewhere. Even if there's just one that you don't understand, tell me now and ask me in the chats. You can even send a direct message. Nobody has to see a message but me. No one? Seth, where did I lose you? You want to send a message in the chat or do you want to raise your hand? Fourth row. The one with 41, 2, 3, 4. This one. With the 36 over 50. Okay. So Seth, remember when they were over 100, they were very easy to convert, isn't it? But now my problem here is my fraction is over 50. So I want to make it out of 100. So I decided to multiply by 2 because we just learned about equivalent fractions. So that just gave me 72 over 100. Right. Now, if you could understand this one over 100, then this will make it much easier. So guys, if you don't have a calculator and they say to you, convert these fractions, try and get them over 100. Okay, Seth, did I sort of answer your question? Are you fine? Are we fine? You have to figure out the two, Caden. How do you get 50 to 100? You have to times it by what? I'm going to come back to Deborah, don't worry. Okay, I'll do another example. But Caden, how do you go from 50 to 100? You have to multiply it by something. Remember, we want a denominator of 100. Exactly. So that's how I decided. But Caden, you're not allowed to only times the bottom. You must also times the top. Remember how equivalent fractions work? Whatever you do to the bottom, you must do at the top. Whatever you do at the top, you must do it at the bottom. So that's why I times it with 2 at the top and the bottom. So now my new fraction is 72 over 100. Okay. I don't understand how to convert decimal to a fraction. Okay. You're welcome. Okay. Who asked that? Deboho. Okay, Deboho, let's look at decimal to a fraction. If I have 0.25. Okay, so Deboho, you're going to take this number over here as it is. Okay, in this case, it is a 25 over. Now, it's either going to be over 10, over 100, or over 1,000. But you decide by how many values are after the comma. So how many values are after the comma? We have a 2 and a 5. How many are those, Deboho? How many are those? If you have a 2 and a 5, then we have how many digits after my comma? Is Deboho still here? There we go. We have 2, right? That means your denominator is going to have 2 zeros. Okay, so this is 25 over 100. But then you simplify it because 25, if you divide both by 25, divide by 25, then it will end up being 1/4. Did I answer your question, Deboho? Let's do another one. Okay, if I have 0.05, I said you put that number as is, 5 over. How many digits do we have after the comma again? How many digits are after the comma again? 2. So it's still over 100. So the zeros before the numbers will count. But if I have 0.5000, these are not going to count. We're only counting up to there. Okay, so 5 over 100, and again, you simplify to 1 over 20. You're going to divide both by 5. Did I answer your question, Deboho? Wonderful. Okay, Seth asked me for one more example. I'm going to go from a fraction that isn't over 100 so that I show you what we're doing. Okay, if I say 3 over 20, né? And I say I want it as a decimal and as a percentage. We'll do our brain break at the end. Don't panic, guys. Now we have a 3 over 20, which is not over 100. It's going to be very difficult to know what the decimal is, right? So I want my denominator to be 100. So tell me, guys, how am I going to get from 20 to 100? Check again, Caden. You're very close, but you're off by 1. By 5. But what I do at the bottom, I have to. What I do at the bottom, I have to do at the top. So if I'm going to times by 5 at the bottom, I have to times by 5 at the top. So then my new fraction will be, what? We know this is over 100. 15 over 100. Now, is this not a bit easier to work with? Because now it's already over 100. So tell me, guys, 15 over 100 will be what as a decimal? It will be what as a decimal? Yes, Seth. But remember, Seth, the fraction was given to us. So we already had 3 over 20. So we just did this whole thing. This part is to help us answer the other blocks. So you don't have to do it in the table. You can do it on the side just to check if you don't have a calculator. Then as a decimal, it will be 0.15. And as a percentage, it will be, as a percentage, 15%. So do you see what I meant, Seth, by making it over 100? This is the case when we are given the fraction. So we can use our fraction to help us answer the decimal and percentage part. And if it's over 100, it is so much easier. You're welcome, Seth. Okay, I'm going to have a final thumbs up, thumbs down for us. Thumbs up, thumbs down. Are we good with everything we have done today? Now is the time to ask questions. Should I zoom out for people who want to take screenshots? Let me do this. There we go.